Hi, everybody. Welcome to the Unit 2 test review. So this first set of problems, 1A and 1B, are very similar to each other. That's how this review is set up. Then 2A and 2B are kind of similar to each other. So in this first example, we have parentheses. We know that's distributive property. But one common mistake that I see very often is distributing this 3x when it actually reads 4 minus 3x minus the quantity 2x minus 6. So we're not distributing a 3x. We're actually distributing, a negative 1. So I'm going to write a 1 in front of here, and I'm going to distribute. So I have 4 minus 3x. And then if I distribute a negative 1 to 2x, that's negative 2x. And then a negative 1 times negative 6 is positive 6. Now I'm looking for my like terms. So my like terms are going to be my terms that have the same variable to the same power. So negative 3x and negative 2x are like terms, and 4 and 6 are both positive, and they are like terms. So negative 3x minus 2x is negative 5x, and positive 4 plus 6 is 10. Over here on 1b, same thing. I'm going to distribute negative 1. So I have 6 minus 8x. Negative 1 times 4x is minus 4x. Negative 1 times negative 7 is a positive 7. So again, I have my constants that are both positive, and negative 8x minus 4x is negative 12x. 6 plus 7 is 13. Okay, next set. We are actually solving here. So my variable is v. That means my answer is going to look like v equals and then a number. So when I am solving equations, I'm really doing PEMDAS or order of operations backwards. So the first thing that I'm going to do is I'm going to subtract 6x from both sides to isolate my term with my variable. And 10 minus 6 is 4. Using my inverse operations, I'm going to multiply by the reciprocal. So the reciprocal of 2 over 7 is 7 over 2. And I'm going to multiply that on both sides of my equation. So the reason why this works is because 7 times 2 is 14, and 2 times 7 is also 14, and 14 divided by 14 is 1. So this side cancels out. I'm just left with v equals 4 times 7 is 28, and 28 divided by 2 gives me 14. Same kind of thing over here. I have a plus 5, so I'm going to do inverse operations, and I'm going to subtract 5 from both sides. So that's 3/4 w is equal to 10. Next step, the inverse of 3 over 4 is 4 over 3. And I'm going to multiply that on both sides. So 4 times 3 is 12. 3 times 4 is 12. And 12 divided by 12 is 1. So those 4's cancel, those 3's cancel. We're left with w is equal to, then 10 times 4 is 40. 40 divided by 3 is not a whole number, so I'm just going to leave this as 40/3. Oh, I don't need to do that. Just scroll down. Okay, 3a. Again, we see distributive property, but we have variables on both sides of the equation. So I'm going to start by distributing. And then I'm also going to distribute on this side, or the equal side, to both terms that are inside of my parentheses. So I have 2 times 6a is 12a. And 2 times negative 4 is negative 8. 4 times 3a is 12a, and 4 times negative 2 is also negative 8. Now you may notice right here that I have the same thing on both sides. So let's see what happens. When I go to solve an equation with variables on both sides, I'm going to move my variables to the left side of the equation. So since this is a positive 12a, I'm going to subtract 12a from both sides. And I'm left with negative 8 is equal to negative 8. Well, it sure is. So I'm going to call this infinite solutions. And what that means is any number that I pick, positive, negative, fraction, decimal, is going to make both of these sides of this equation equal to each other. Any number that I pick for a, if I substitute it here and substitute it here, I'm going to get the same thing on both sides. It doesn't matter if that number is positive, negative, fraction, decimal, everything will work. Okay, let's see if the same thing happens over here on 3b. So I'm going to distribute my 9, and then I'm going to distribute my 3. So when I distribute my 9, 9 times x is 9x, and 9 times 1 is 9. 3 times 3x is 9x, and 3 times 3x is 9x, and 3 times 4 is 12. Okay, so same thing. When I'm solving with variables on both sides, I am going to move my variables to the left using inverse operations. So I'll subtract 9x because this is positive. And then over here, I'm also going to subtract 9x. And in this case, again, they both cancel out. And I'm left with 9 is equal to 12. Well, that's not true. 9 and 12 are not the same thing. So we're going to call this no solutions, which means that it doesn't matter what number I pick for x, whatever number I pick to substitute in for x, positive, negative, fraction, decimal, nothing will make this left side of the equation equal to this right side of the equation. There's nothing that would work. Okay. We see this kind of special case of an equation where the entire left side is a fraction. Entire left side, or it could be the right side, but the entire side is a fraction. So in order to get rid of a divide by 3, when the whole entire expression is divided by 3, we're going to multiply by 3, both sides. 3 and 3 are going to cancel. I'm left with 4a minus 2. 6 times 3, 18. Now this looks like what we were working with before. So inverse operations to finish it off. I have a minus 2, so I'm going to add 2 to both sides. So 4a is equal to 20. I see multiply by 4, so I'm going to divide by 4, and a is equal to 5. All right, over here, same thing. I have divide by 2. So on both sides, I will be multiplying by 2. My 2's cancel, so I'm left with 5b plus 6, and 13 times 2 is 26. I see a plus 6, so I will subtract 6. 26 divided by 6 is 20. I see a multiply by 5, so I will divide by 5, and 20 divided by 5 is 4. In the next section, we have literal equations, and literal equations are when we have multiple variables. A lot of times we don't have a lot of numbers, and usually these are formulas. So this says the area is equal to the height times base 1 plus base 2, all divided by 2. And we are trying to solve for base 1. So we want to get base 1 by itself. It's right there. So we've got to think about how we're going to get all these other variables away and on the other side. So b sub 1 is by itself. So just like this last equation, I have a divide by 2. So on both sides, I'm going to multiply by 2. So 2a is equal to h times the quantity base 1 plus base 2. I see multiply by h, so I'm actually going to divide by h. So on both sides, I'm going to divide by h, starting to get down to base 1 being by itself. Now, all that's left to do is that